Our group topic is long-term sentence preprocessing in neural machine translation. And I will from introduction methods, experiments and results, and discussion these four aspects to introduce our work. First, for neural machine translation has many challenges, for example, such as out-of-domain, amount of training data, low-frequency words, long sentences, and word-aligned model. For long sentences, it contains ambiguity in grammatical structures, semantics, and neural machine translation have lower translation quality on very long sentences than statistical machine translation. To solve the problems, many people have different methods to solve the long sentences translation model problems. This one splits the long sentences into different short sentences separately, and the other one splits the long sentence for phrase-based statistical machine translation using linguistic information, and others build a phrase-aligned bilingual corpus where extract the bilingual phrases. And our work based on Tian and Min's work. First, build a phrase-aligned bilingual corpus, and then use the corpus to train an NMT translation system. And finally, we will compare the results. And I will introduce our methods. Our main idea, I just introduced. So instead of removing long sentences, our main idea is to break down these sentences into phrases and put them together with the training corpus. So how to break down the sentences into phrases? We're using the Moses to extract long sentences of which has more than 13 words, and then select the phrase pairs where the condition probability both this equal to 1. Then we select them into the training dataset, and finally we use the combined dataset to train a model. So we use GICA++ toolkit on Moses to score the aligned phrases to select the good quality phrases, and add them into our training site. Um, this this is our phrases selection algorithm. Um, Next, I will introduce our experiments and the results. The baseline model using the OpenMT to train an MT model, um, which is a LSTM encoder-decoder model, which has 6 layers of encoder and decoder respectively with SGD optimizer, and we set the training steps 100,000 and the validation steps is 5,000. And using phrases extracted from the bilingual corpus model with transformer model, and 6 layers are the same as the LSTM, but with an ADM optimizer, and the learning rate is set to 2. And the training steps and the validation steps are the same as the baseline model. And this our result. This our data size. And this our result. We found our model performs not well. We think there are 4 reasons for this. First is the size of our training set is not enough. Second, lack of data normalization. And third, without a fine tuning, and we can't cite the good hyperparameters properly. Well, next we will fix the problems in the future work. Thanks, everyone.